hydrocarbons going.
Straight up and on there. They're all over.
Look if you want to do it again.
All right, let's get started. Branched. What's going on out there?
A party?
That was the late though, right?
Hooligan.
There was a fight?
Hooligan.
Oh, no, I don't know.
Branched hydrocarbons. All right, so let's draw something here. Let's do. Yeah, draw that, and then.
What? Today's date. You okay, Matt?
All right. I want you to draw this, and then I'm going to try and draw it again a different way. But it's going to be the same thing. Because I want to make a point here. That's going to confuse people a little more, isn't it? Let's try it from this side. Alright. Draw those two. And then we'll talk about them. Alright, so everybody ready? Oh, I've got so many. Okay, that's just something. No, that's fine. Okay. Alright, so on the left here, what it appears to be is that we have 6 carbons in a chain, and then 4 carbons coming off the side. So there's 6 carbons in a line, more or less, right? I can twist them around and make them straighter. And then here's 4 more coming off the side, right? So that's kind of what this looks like. Okay? Now this one here, what it appears is that we have 8 carbons and then 2 more coming off the side. So here's 8 carbons in a row, and then here's 2 more coming off the side. Now what do you notice? Huh?
That's not obvious at all.
So what do you notice about these two?
The same.
They're the same thing, right? I drew them slightly different, where here it looks like this is coming off, and here it looks like this is coming off. But it's actually, you know, it's not like one comes off at 90 degrees. They just branch off separately, this piece and this piece. Okay, so this is important that you get that these two are the same thing. Because when we name this, we want to have one naming system, right? We don't want to have 2 separate names for the same thing. That'll be really irritating. So what we need to do when we name this is we need to figure out which chain is the longest. Is it from here to here, or is it from here to here? So that's what's going to matter the most. So let me give you the rules first, and then we'll start naming this. Go ahead.
No, I didn't say anything.
All right. So rule number 1, identify the longest chain. So for this one, it's really going to be from this carbon to this carbon. That's going to be the longest chain. It's 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, I can't teach you to go up. This just pisses me off too much. All right, so it's going to be 8 carbons. So that's our longest chain, and that means that this is going to be the side chain here. And it's the same thing up here, right? Because it's the same drawing. So on this one, it's still the same thing. 1, 2, 3, 4, 5, 6, 7, 8 is our longer chain, and then 2 carbons off to the side is our side chain. Okay? So, identify the longest chain. This is called the parent chain. Okay, and that's going to come at the end of the name. So whatever we name this thing, it's going to end with octane, because the parent chain has 8 carbons. Okay, so it's going to be something octane. Okay. Now, number 2, number the carbons starting on the side closest, there's an S there, closest to the side chain. Okay, so using this drawing, they're both the same. The side chain is closer to this side. If I do 1, 2, 3, 4, so the side chain comes off carbon number 4. If I started from here, it'd be 1, 2, 3, 4, 5. So I want whichever gives me a lower number. 5, 6, 7, 8. Is anybody confused by this drawing? Do you want me to draw this the old way, or are we okay with this?
I don't know what I am.
I don't understand this at all.
Yeah, I don't
know.
All right,
I'm a little
so
confused.
let me take this here. These are two that are the same, but let me take this and draw it the old way before I finish what I'm talking about. Okay, so here we got 1, 2, 3, 4, 5, 6. So carbon, 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 carbon. There's 6 in a row. And off of number 4, there's another chain here. Carbon, 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 carbon. I should have left some more room there. So this is what that is, along with all the hydrogens, right? There's going to be a hydrogen down there too. You just throw it in there. Okay, and what I want you to get from this is that even though I made this one turn at 90 degrees, it doesn't really happen that way, right? In reality, they both kind of go off at 2 angles. This one goes off like this, and this one goes off like that. So there's no correct one that goes straight, right? So the way I just numbered it up here, this is 1, 2, 3, 4, 5, 6, 7, 8. So it cuts off.
What about the other 2?
So those are not part of the longest chain. So these are a side chain. Right? So what you have really, right, the first 4 carbons are in a line, right? And then you got a long chain and a short chain. But really they branch off diagonally, right? Even though we draw it at a right angle and straight, it's really like this. So the longest chain will be this, and the side chain will be that little piece, which is these 2 carbons here. That's the side chain. We know it's the side chain because the rest of it's the longest chain, right? So we're trying to make the longest string of carbons we can, and that's the 8, not the 6. All right. Hope that makes sense. Let's continue. Rule number 3. Okay. 3, add prefixes if necessary. It's not here. We only got one side chain, so no prefixes. I'll show you those later. 4. Name substituents. Substituents are the side chains. They're substituted in place of a hydrogen. In alphabetical order. And since you don't know what they are yet, don't worry about that, but in a second, it'll make sense. It's alphabetical order. So for the moment, just get the rules written down. We'll name this thing, and then it'll make some more sense in a second.
That's the last rule.
That's the last rule. All right, so what we have here is 8 carbons on the main chain, the parent chain, so that's going to be called octane. And our side chain has 2 carbons. So since it's got 2 carbons, what do you think we're going to call that? Well, 2 carbons usually eth something, right? So it'd normally be ethane, but since it's a side piece, we call it ethyl. So it's going to be ethyl octane. And since this comes off the number 4 carbon, we're going to call it 4 ethyl octane. So the 4 indicates the position of the side chain. If you want to look at this one, it's 1, 2, 3, 4, right? And ethyl tells us there's 2 carbons on the side chain.
Why are there 2 different ways to draw it?
I was hoping that would make it less confusing.
Well, that's confusing me, and that's confusing.
Yeah, but see, here's the thing. If you were drawing this and you didn't know which one was going to be the longest, you might start drawing this side first, then draw this as a side chain. But they're really the same thing. It's the way we draw it, it makes it look like there's one that's coming off the side, but in reality, in 3 dimensions, neither one comes off at 90 degrees, and neither one goes straight, right? So it's the failure of trying to draw something in 2 dimensions. It doesn't come out perfect. All right, so that's what this is. Let's draw some more, and then I think this will make more sense. So let's just try another one. All right, what if we got 1, 2, 3, 4, 5, 6, 7, okay? And we got that there. Okay, actually, let's just make this 1 carbon. I want it to be 2. There we go. All right, so the parent chain, what's it going to be called? What is it? You miscounted. It's going to be 1, 2, 3, 4, 5, 6, 7. So what's that? That's heptane, right? Heptane. All right, now my side chain. It's got 1 carbon, and it's on number 3, right? So what's this going to be called? What is it? Well, it's only 1 carbon. If it was 2 carbons, it would be ethyl.
Methyl.
Methyl. So it's going to be 3-methyl heptane. So there's your methyl group, that single carbon. It's coming off the number 3, so it's 3-methyl. Let's go down here. 1, 2, 3, 4, 5, 6, 7, 8. Let's do this, and let's see, then we'll do this. All right.
Whoa. That's
So we got 2 side chains.
octane.
Octane, right?
And 1, 2, 3. And
1, 2, 3. So what's it going to be?
3, 4.
Well, so what we do is we name them one at a time. So this is what? What's this piece called? 3-methyl, right?
And 4 ethyl.
And then 4-ethyl octane. Okay, so we're just naming the 2 groups. Now I broke my rule. We're supposed to do it alphabetical, so we should have listed the ethyl first. Don't worry about that.
But that's only confusing because methyl comes before ethyl.
Yeah. Usually alphabetical is how we do it. That's it. Just don't worry about that. Let's just do a couple more. What if we have something like 1, 2, 3, 4, 5, 6, 7. Okay.
Hold on. Go copy the other.
Seven.
That's
So
heptane.
that's heptane. It's going to be 1, 2, 3, right? So there's a 2 and a 3. They're both methyl.
So
it
2,
says,
3 methyl.
yeah. So since there's 2 of them, we're going to put a prefix. So it'll be 2, 3, and we'll say dimethyl. That's just 2 methyls. That's heptane. You okay with that?
So we want to do that alphabetical?
Well, there's only one thing. They're both methyls. If there was methyl and ethyl and propyl, we would name them in order of, which one comes first alphabetically. All right. let's try the reverse. How about if I give you the name and we'll try and draw it. Okay, so let's do 3-ethyl 5-propyl. Propane is 3 carbons, right? So propyl will be 3 carbons. Decane.
It's a little word.
Yeah, it's maybe that. All right. So what are we going to draw first?
10 thingies.
Yeah, we're going to start out. We're just going to draw decane first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your parent chain. And now you can start on either side, right? When you're drawing it yourself, you can make this number 1 or this number 1. It doesn't matter. So let's start here. This will be 1, 2, 3, 4, 5. So 3-ethyl. So here's number 3 carbon. It gets an ethyl. That's 2 carbons, right? And then number 5 gets a propyl, which will be 3 carbons. So it'll be like 1, 2, 3. Should we do one more or are we good? Good. Questions? Okay, if I ask you for the formula, just count up all the carbons, and just like the alkanes, you double the number of carbons and add 2. So this is like decane is 10, 11, 12, 13, 14, 15. So this would be like C15, H, 2 times 15 is 30, plus 2 is 32. So you can do that. Same as the alkanes. All right. You're done. All right, Jose. Thank you.
What happened to those?
I have no idea. Oh, you mean like my numbers? There will be a 9, which will be some